We'll now look at section 2.5 and begin our discussion on linear inequalities in two variables. We'll first begin with a procedure table. When we have linear inequalities with two variables, and recall that this would be a problem where we have a less than or a greater than or equal to or less than or equal to, and we also have two variables, so maybe an x and a y. Our first step is to graph the line that results from replacing the inequality with an equal to. Step 2 is to make the line solid if the inequality symbol is less than or equal to or greater than or equal to, and we make it dashed or dotted if we have a less than or a greater than. And we'll look at this with an example in just a second. A solid line indicates that points on the line are included in the solution set, while a dashed line indicates that points on the line are excluded from the solution set. Step 3 is to determine which side of the line or which of the half planes defined by the boundary line solve the inequality, and we do that by substituting a test point from one side or the other into the inequality. If the resulting statement is true, then all of the points on that side solve the inequality. Otherwise, the points on the other side solve the inequality. And we shade the half plane that solves the inequality. So let's keep these three steps in mind and look at a couple of examples. We'll begin with the example 3x plus 2y is less than 12. And we want to solve that linear inequality by graphing the solution set. So remember that step 1 says that we want to graph the line that results from replacing the inequality with an equal to. So what that means is that we're going to take our problem, the 3x plus 2y is less than 12, and we're going to write it 3x plus 2y equals 12. And we're going to try to graph that. Okay, so let's look at how we do that. So we know that we can graph an equation by doing a table of values. We also know that quite often the intercepts are the easiest points to graph. So I'm going to let x equal 0, and I'm going to let y equal 0 for my second point. And let's solve this and find the missing variable. So if x is equal to 0, I'm going to say 3 times 0 plus 2y equals 12. The 3 times 0 cancels out, leaving me 2y is equal to 12. And so 2 times 6 is equal to 12. So I know that I have the point 0, 6 as one point on the line. If the y value is 0, 3x plus 2 times 0 is equal to 12. The 2 times 0 cancels out, leaving us 3x is equal to 12, and we know that 3 times 4 is equal to 12. So we also will have the point 4, 0. So what I can do now is I can go to a graph and plot those 2 points, 0, 6 and 4, 0. And you'll see that that's been done on the next slide. So our points are 0, 6, and 4, 0. So on a graph, you're going to plot those 2 points over 0, up 6. Okay, so here's the first one. And 1, 2, 3, 4, up 0 would be the second point here. And we're either going to connect those 2 points with a dotted line or a solid line. And remember, when we look back at our steps, how do we know which of it is that we're using? It says make the line solid if you have a less than or equal to or a greater than or equal to. Make it dashed if you have less than or greater than. So our problem had just a less than in it. And so if our problem only has a less than in it, then we're going to make it a dashed line. And so that is why this line is dotted as we extend it down. Now, the next thing that we have to decide is which side of the line represents the solution set. All right, and remember that our procedure table tells us to pick a test point and substitute that into the equation. All right, so let's do that. Let's go to our equation. 3x plus 2y is less than 12. 3x plus 2y is less than 12, and I want to pick a test point on one side or the other. So it does not make any difference what you select. I'm going to pick something that's easy. I think I'm going to pick 0, 0 because I know that that will be a super easy point to plug in. But you want to plug in some point over here or some point over here, not a point on the line, but anything else would be okay. So I'm going to plug in 0 for x and 0 for y. And so what that gives me is 0 plus 0 is less than 12. 0 is less than 12. Is 0 less than 12? Yes, and so if it is a true statement, then we know that 0, 0 is one point that is a solution to this equation. And if I prove that I have one point over here that's a solution, then every point on this side will be a solution. And so what I then need to do is come in and say everything over here, shading this entire side of the graph, represents the solution to the linear inequality. If we had gotten a false statement over here, we would have then shaded on the other side. All right, so let's go on to part B of our problem. Part B has the equation x minus y is less than or equal to 0. We want to, again, be able to graph that line. So let's see. Let's take this and let's first, as we were told, make it an equal to problem. So x minus y is equal to 0. And I'm going to solve it for y, and I really want to solve it for a positive y, so I think I'm going to add the y to both sides, moving it over to the right. And so our equation becomes x is equal to y. And so if we do a table of values for that, we can really use anything. I could use 0. If I plug 0 in for x, then the y also has to be 0. That gives me 1 point right there. What if I use the point 3 for the x? Then we know that the y also has to be 3. And so that gives us 2 points that we could connect to make the line. Now again, do we need to draw a solid line or a dotted line? And we look at our inequality here, remembering that if it is less than or equal to, the equal to is what causes the difference, then we make a solid line. And so we can go ahead, just like we have on the picture, and make a solid line right there. Now the next step is to pick a test point. And so you pick a point. Pick any point that you want as long as it's not on the line. So I might pick, let's pick the point 4, 1. All right, so the point 4, 1 is right here. All right, and so then I'm going to plug that into the original equation. So for the x, I'm going to plug in 4, and for the y, I'm going to plug in 1, and make it less than or equal to 0. So 4 minus 1 is 3, less than or equal to 0. Is that true or not? Is 3 less than 0? Okay, so that is false. And so if it's false, then 4, 1 is not a solution to the inequality, which means that nothing over here solves the inequality. And by default, it must be the other side. And so then we can go in and we can shade everything on the other side as our solution set. All right, for part C of the example, we have x is greater than 3. And so remember that your first step is to make it equal to. and graph it. Now remember that if you have an equation that only has one variable, it is either vertical or horizontal. And if that one variable is an x, then the line is vertical. So we come to 3 and we draw a vertical line. Remember that line needs to be dotted because there's no equal to underneath. So we dot out this line. And then we need to determine which side to shade on. And so you pick a point. Again, pick any point that you want as long as it's not on the line. So I might pick the point, let's pick the point 4, 4. So 1, 2, 3, 4, 1, 2, 3, 4. There's my point. This is my test point. I'm going to plug it into my original equation. So the only thing I can plug in is the x. So 4 is greater than 3. That is true, which means that every point on this side is a solution to the inequality. And so I shade on that side.